Hi guys, Buildzoid here, and this is going to be a very disorganized video, like more so than I usually am, because I literally just put the 14900K into the MSI Z690-A DDR4 motherboard. Yeah, the Pro Z690-A. And I figured we would take a look at how that behaves sort of right out of the box with whatever BIOS is on there. It's definitely not up to date, so yeah, I don't know what we're on. But I just wanted to document like the pre 0129 microcode behavior. So that's what we're taking a look at today. So the out of the box load line is 0.5 to 0.8. That's interesting. Yeah, that's interesting. I mean, it's obviously this is kind of like similar to what Asus uses, but it is interesting. Because the DC load line, at least if MSI cares about maintaining power monitoring accuracy, should be matched to the VRM load line, which if it is, this isn't actually as bad as, say, what Gigabyte does on the Master X board, where the AC load line is 0.4 and the DC is 0.9, but the VRM is at 1.1. So this 0.8, 0.5 setup, this should actually be reasonably stable. If the 0.8 is properly matched to the VRM. If it isn't, then this will be just as like unstable as, say, the Gigabyte boards. Anyway, I have the processor. Yeah, we're going to quickly check that. I mean, I guess I could have just scrolled through hardware info for more information, but yeah. Also, during this whole time, obviously I have the oscilloscope hooked up. Interestingly, we haven't seen the voltage go above 1.536 yet. Then again, I haven't tried to run Cinebench R15 on it, so that might have something to do with that. I also didn't put all the mounting hardware on there. So yeah, we're on like ancient microcode. We're on 113. And I'm just like this is kind of the whole point, is like I'm just wondering how this is gonna behave. I don't even know if this microcode supports 14th gen. So that's fun. So now I do want the sensors, and we're gonna run Cinebench 15. Oh right, I have the hardware info polling rate just absolutely cranked, so it's just going wild. Let's slow that down a bit. Yeah, so we're getting our 6 gigahertz boost, even though I don't know what BIOS version. Like, this BIOS version is probably incredibly outdated. What are our vids like? So far we haven't seen anything over 1.4, 1.5, so that's pretty nice. And I do care about the temperatures, because, wait, what's our power limits? Oh, and out of the box, just completely unlimited. I did clear the CMOS, and I didn't do anything else. Like, I cleared CMOS, and yeah. Like, we don't even have XMP enabled. Not that, like, for Cinebench it matters. So, well, R15 already crashed, so that's as expected, I guess. So I guess we're not going to get to see what the voltage spikes, because it's literally too undervolted to yeah, it's literally too undervolted to be stable. That's one way to avoid excessive voltages, is just set the voltage so low the CPU doesn't even work. That's the thing that, like, I keep saying, right? Is like there's two problems with this platform. One, out of the box, a lot of these motherboards just undervolt the CPU like crazy, which leads to things like this, where you just like it doesn't work at all. And then you have the other issue where it's like when Intel first fixed the fact that the motherboards were undervolting like crazy, they created the the voltage spikes were always there, but they made them much worse. But anyway, hopefully R23 can trigger, because like it shouldn't be specifically 15's load transition that is that bad. It should be any load transition, I think. Yeah, 40,600 points. Man, this is scoring better than the like auto settings on Gigabyte. Actually, that might be because Gigabyte's auto settings for this CPU have a 280 watt power limit, and so partway through the Cinebench 23 test, it actually like starts hitting the power limit. I'm surprised the voltage behavior isn't really that bad. Oh, there we go, 1.56. So I'm just not, like, I'm not hitting it fast enough, basically. I think, like, a really cool thing would be if, like, for internal, like, I'm not even sure, like, for external users, but, like, if you're a CPU manufacturer, I feel like having an internal application that just, like, load cycles the CPU really, really hard would be, like, a sensible thing to use internally for validation. You know, assuming you actually did any. And you could also just hand that out to your motherboard vendors so that they can check if their power delivery is just doing anything weird that it shouldn't be doing. There's like an official stress test, both like, you know, sustained high load and also just something that just bounces the CPU from like low load to high load constantly. It's kind of funny how like a lot of other things can run, but like R15 specifically doesn't run. I wonder if 11.5 does. They're still not getting the super high voltages. Like, yeah, 1.56 is higher than the like 1.55 limit of the newest microcode, but like I thought it'd be worse. I guess one thing we should check is if this board does the thing where TVB works at temperatures where it shouldn't be. Because that was another issue, was that a lot of motherboards would actually get, like, TVB is supposed to not work above 70 degrees Celsius, and a lot of motherboards would actually bypass that, so that you'd get 6 gigahertz even above 70 degrees. Like, a lot of motherboards have bypassed it to the point that you'd get 6 gigahertz all the way to 100 degrees. Though I don't really have a good way of doing that test. Because I think chances are the CPU won't get hot enough with a single core load. Yeah, it's just not going to get hot enough, I don't think. Actually, no, it's 6 and 7, I think, are the boost cores, right? Seven. Okay, no, so this, I don't think this board has that, like, like, the 6 gigahertz lock. Because, yeah, the temperature's, like, bouncing around, like, 70-ish, and you can see how the frequency keeps, like, it's not holding 6 gigahertz. So I don't think this one's bypassing the thermal limit. Core voltages also aren't, like, they're not... Like, yeah, we're getting some peaking up into the, like, 1.52-ish range, but that's actually the same kind of behavior that you would see with the latest microcode. Like, on 129, like, I still get peaks all the way up to 1.54. So... yeah, that doesn't seem like there's anything really wrong with this. So that's cool. Yeah. So this is actually better behaved than I thought it would be. I mean, it's not stable, but like it's not completely insane like I thought it might be. I guess at this point, you know what? Let's just update the motherboard live. Where's my USB stick for flashing BIOSes? I didn't prepare any of this. It just seemed like a good idea to document, like, you know, where we started to where we're at now. To have, like, because I don't, like, the thing is, I think a lot of, like the default behavior of the motherboards, like, there wasn't, like, you didn't really pay a lot, I didn't pay a lot of attention to it. I'm not sure that a lot of other people paid much attention to it. Because, like, the assumption is, right, like, Intel gives the motherboard vendors a spec, and the motherboard vendors follow the spec, and things work. and then it turns out that the spec was like, do whatever, and the motherboards did whatever, and turns out that was a terrible idea. And then when Intel started locking things down, they found out that there's all kinds of bugs everywhere, right? Like there was a TVB bug, then we had the voltage spikes bug. So anyway, let's go update the BIOS and see how things change. Like at the bare minimum, I expect the 129 microcode to fix the instability in R15. Okay, so where's the flash tool? There. Okay, looks like that's the correct... Man, I was confused because, like, usually I pull the BIOS file itself out of the folder, but this time I put the whole folder in. So I wasn't sure what I was looking at. I'm kind of wondering if, like... Like, the issue is like, with judging whether, like, one motherboard vendor was better about, like, treated the CPUs better out of the box than another, is that you don't know how many, like, how popular those motherboards are, right? So, like generally speaking, Asus is the most popular motherboard manufacturer. So pretty much anytime something goes wrong, you're gonna have, if there's like a platform-wide problem, you're gonna have Asus people complaining about it first, because they're just the most, like, there's more Asus motherboards than anything else. So if there's something wrong with the platform, Asus is like probably gonna be hit first, just due to the size of how many boards they have sold. So it's like really hard to judge if like MSI or like if some other manufacturer is just better at like not like had less aggressive out of the box settings, or if it's just like there's less of those motherboards. Now, there was also a management engine update included with this BIOS, but I'm not sure if that's actually necessary. I would kind of hope it isn't. And assume that it probably isn't, because, like, yeah. And I think I might have already updated the... Well, I'm not sure if the management engine... No, that's for the motherboard as well, so I might have to update that as well. Well, we'll see. So anyway, now I'm going to reset the statistics on the scope so that we see what this new BIOS does. So if anything, I actually expect this new BIOS to get higher voltages on the maximum readout, just because it's going to remove the undervolt that MSI had out of the box. But if Intel, if, you know, the microcode is working correctly, we shouldn't be seeing anything more than 1.55. Oh boy. Well, that's really bad. What did I just flash? Oh, what is this? Oh, oh, wait, no, that's the installer. No, we don't want the installer. I want the tool. So, well, we're not off to a good start because we already have 1.6 volts on the scope. That's amazing. No, don't tell me I already broke the thing. No, this is Microcode 129. Oh, boy. So, no, go away. No, go. What? Yes, I want to quit the installation. Okay, so yeah, this is Microcode 129, and this is not working correctly. So the main well, I'm assuming that the board didn't default to Intel settings. Because if this is on Intel settings right now, then this is not working correctly. Come on. Okay, let's check them load lines. I'm assuming we're on 1.1 for everything, aren't we? Yep, 1.1 across the board, and the microcode doesn't seem to be doing the thing. Because, like, that in and of itself shouldn't cause, like, the vid limiter should be blocking us from seeing voltages this high. So, regardless of what the AC load line is. So, this isn't working right now correctly. Now, this might be because it's not actually on Intel default settings right now. But that's still bad because as far as I know, at this point, the motherboard vendors are supposed to, like, clear CMOS should give you defaults, like Intel default settings. This definitely isn't doing that. And actually, do we have what's our power limit? We do have the power limit. Oh, that's weird. So maybe it also needs the management engine update? Yeah, so when the... Okay, so now this doesn't crash anymore. I'm just going to reset the statistics, but... Oh, wait, I don't have the option to just, like... Oh, there's 1.53. 1.54. Yeah, it happens both at, like, right at the start of the test and right at the end as well. But we also got a spike, like, coming into coming... Maybe, like, the BIOS wasn't, like, properly initialized or something, which is why we got that big spike during startup? Yeah, because right now it actually seems to be behaving roughly how, like, it's supposed to. Like, we're not going over 1.55. If I look at my max vid was 1.525, 1.545. Kind of wondering if there's maybe, like, some thread count that's, like, more... Just, like, load up the P cores and nothing else. Because that can sometimes do some interesting things. Nope, nothing. So that is very, very odd. So that does look like the limiting wasn't, like, on until we got into Windows. So I'm just gonna do a restart. Actually, let's take a peek in the... Oh, I missed the BIOS. Oh well. Yeah, so like as Windows is loading in, we get these insane voltages. Why? Like, why does it need the OS running in order to work? Like, really, like, the problem I have with this is, like, having a safety feature that relies on your operating system being the core. Like, that just, like, your your CPU's health should not be dependent on the operating system that it's running. Okay? Like for comparison, an NVIDIA GPU, before it boots up, like before the driver initializes, will literally not enter high power states. It just won't. Until it has a driver, it's permanently stuck at like 2D clocks. So in like low power settings, actually, it's not even stuck at like true 2D clocks. It's stuck at like an initialization mode. Because modern... Yeah, because I think like a lot of NVIDIA GPUs, like you'll have the GPU like start at like 0.9 volts, as that's just like a typical... Actually, I'm not sure if how this works for 40 series, but there is a lot of GPUs, older GPUs, not necessarily the most modern stuff, where it'll like boot up at 0.9, and then once the driver initializes, it'll drop the voltage for like an even lower idle state. But if the driver doesn't initialize, you're still on that like like you're locked at 0.9 volts, and you don't get full 3D clocks, and you don't get like the thermal limit is still functional. So even if you booted without a heatsink, the GPU will shut down before it overheats, right? And you don't have the option to get extremely high voltages. Like that's just not gonna happen because it's like not capable. Like it won't make those kinds of like it just won't do that. Um. I think this is... Wait, it's this probably, because that says 2024, so it should be this, I think. I really wish, like, the MSI... Well, it is MSI firmware tool, so it has to be the right one, isn't it? Oh, wait, we're already up to date? So that's not it. I mean, you know what, I'll run it just in case, but... Like, it doesn't make... Like, it just doesn't make sense to me that you would let the CPU have, like, why would you even just... Like, is TVB, like, is like, TVB not active or something? Like, before the OS starts up? Which just seems like that seems like a terrible idea. Actually, my current stance on, like, the whole implementation of TVB is that it's horrible, because the way TVB is set up is that it basically tries to rein in the insanity that is the upper end of Intel's vid table. Right? Because if you turn TVB off, it doesn't disable 6 gigahertz boost. It just disables the thermal limit. And we got 1.57 volts on the scope again. And then once we're in the OS, I don't think we ever get it going over 1.5. But like before the OS initializes, like evidently the limiter isn't working, which is just like... Like, that's bad. Like, that should not, you know, like, it should not work like that. I don't, like, there should just not be a scenario in which the CPU can request self-harm levels of voltage. Like, you know, like, it doesn't matter what software is running, like, unless the end user goes into the BIOS and goes, yes, I would like to destroy my CPU, the CPU shouldn't randomly do that. I don't care if it's like, well, the OS isn't running or whatever. No, like, the CPU should not request insanity voltages. Unless, like, the user explicitly tells it to do that. So yeah, like, because once we're in Windows, it really looks like the limiter is on, right? And then as soon as I restart it, like, we get, like, crazy voltages. Now, the fact that it only happens on restarts probably means it's not going to damage a CPU very quickly, but it still shouldn't happen, as far as I'm concerned. Like, that just shouldn't happen. Like, I don't get how you end up in a situation where your CPU just, like, gets to tell the voltage regulator, hey, I want 1.6 volts. Yeah, so I can't get it to go over 1.53 right now, but if we restart, I bet it's going to go over 1.53, like 1.55 again. Which is, like, that's just not good. Yeah, it's like, what, and it actually, it's not even before the OS, because this is Windows loading. Right? Like, this is as it starts loading Windows, it does this. So it's not even like I don't get it. Like, what? Yeah, I just don't get how that happens. Like, why would the limiter not be on until Windows is fully initialized? That just doesn't make any sense. .58 this time. Yeah, so it actually just, like the limiter just doesn't work until Windows is running. Like, what? For comparison, I never saw that with the Gigabyte board. So I don't know what MSI is doing here, but, like, that is, yeah, that's definitely not supposed to happen. Like, on the Gigabyte board, on, like, the before 129, yeah, I would sometimes see insane voltage spikes booting up. But after 129, like, no matter what I did, I didn't register a spike on the oscilloscope higher than 1.55 volts. Like, it would basically top out at, like, 1.541 or something, right? So, but here, like, we're on 129, and, like, sure, once we're in Windows, I can't, like, I mean, I didn't, like, you know, running Cinebench 15 a bunch of times probably isn't an exhaustive, like, verification method. But at least on the Gigabyte board, on the, like, unsafe microcode, that would very reliably go over 1.55 volts. Here, it doesn't do that with Cinebench 15, but then, you know, you restart Windows and it just goes to, like, 1.58, 1.59. So yeah, I don't get what's going on with that. So if I enter advanced mode as F7, right? Yeah. Intel default settings, MSI. So yeah, this is Intel default settings. Do I even want to know what the MSI default settings? May reduce system stability. Oh, so this is just going to go right back to the I can't run Cinebench 15 at all. But I imagine this will actually have lower max voltage. It just won't be stable because it's undervolted. By lowering the AC load line. Wait, no, it did 1.58 again. Oh, this is worse. So that, like, I'm not even sure that the first BIOS I was using is even, like, compatible, like, is even a 14th gen BIOS. I mentioned that earlier. But, yeah, so, wait, so what's the, like, okay, what's the load line now? Oh, it's still 1.1. Oh, that is so much worse. So now we don't have the Intel safety stuff, I think. It's not going to crash, though. So... But I think now we're going to see it spike even after Cinebench, maybe. Oh? No? Okay, so it only happens during Windows startup? What? What's so special about restarting the OS? Because, yeah, this looks like this doesn't look like they turned the limiter off. Yeah, this behavior right now looks like what I expect from the limiter. So it just spikes when the OS is low. I don't get it. I actually do not get it, like, at all. Like, why, when the OS, like, just, like, specifically when the OS is loading, it spikes super high, but otherwise it just doesn't? Like, what? We're gonna go single mode, and I'm gonna restart, and we're gonna see if I can catch the spike. Because I want to see what it looks like, because it might be something like, maybe the voltage regulator on this motherboard is just bad. But if it's like a big... So if it's just like a really narrow spike, that's just... Okay, that's probably the voltage regulator doing voltage regulator things. If it's a big fat block, then it's a vid request. Oh. Huh. So my coax is running kind of close to some of the phases, and I didn't bother to put like a shield between the... Like I didn't put a... Yeah, like... I made a video about this, but if you run the coax too close to a VRM phase, it'll still pick up some switching noise. But that really doesn't look like VRM switching noise. That looks... I don't know what that is. That's not... I don't think that's a vid request, though. That looks like some kind of voltage regulator weirdness, but I don't know what voltage regulator weirdness. Also, why does it only happen when Windows is starting? Like, why doesn't it happen any other time? Like, the vid request itself at this point is probably somewhere around 1.5 volts. And then we just get this, like... This. Like, I don't know why we get this. Yeah, like, I just don't know what that is. Like, I actually just have no idea. Let's do another restart. Because it's just kind of randomly a bunch of spikes. It's not even spikes, it's like wobbling. Okay, no, that's not switching noise getting into the signal. And it's not a vid request. This is like voltage regulator weirdness. Because if it was a vid request, it would be like a big fat block. This is not a big fat block. These are spikes. And admittedly, so the Z790 OS Master like does have a much more elaborate power delivery system than this board does. Right? This is actually, I think this is literally the cheapest Z690, not even Z690. This is the cheapest LGA 1700 motherboard I have. So it having not so great power delivery behavior is not really that surprising potentially, but it is concerning. Like maybe, like, is it? I don't know. Like, I am not thrilled about seeing that on the oscilloscope. I should probably not be seeing something like this. Oh yeah, we get another one. There's several of them. This one's 1.6. So this, yeah, this really looks to me like some kind of power delivery issue with the board. This isn't the CPU being stupid. This is the board being stupid. But why? Because I don't think we have like a super cranked LLC or anything right now. Because like that would potentially make sense if the load line calibration was through the roof, like was like flat. But it's not. Like we have, like we should have plenty of E-droop right now. So this is one weirdness. So the VCC Sense thing on MSI boards, that's not actually true die sense voltage measurement. Okay, that did not help. Oh boy, what is this? Yeah, like you can see the blockiness of the vid requests, right? Wait, oh, I'm on a wrong. There we go. Yeah, like you can see, like this is a vid request. This is a vid request. This is a higher vid request, right? We have this like flat ledge, and we have like transitions between the vid requests. But this right here, that is not a vid request. That is, I don't know what that is. But I probably shouldn't be seeing that. So, oh boy. So I thought it might be something like the reason I changed from VCC Sense to Socket Sense is because the VCC Sense actually changes the load line slopes on MSI motherboards, which is kind of concerning. Because I kind of suspect that they're literally taking the positive connection of the die sense and just feeding that into the Super IO, which is like, I don't know if this is definitely what they're doing. I've not seen the schematics of how the VCC Sense is set up, but that's been my suspicion for a while, and that would potentially cause weird issues. But that, like, changing it to Socket Sense didn't help. So I do have a fan on the VRM, so we're just gonna like max out the switching frequency and. I haven't, yeah, I don't, I'll have to like manually measure the load line slopes on this board because unfortunately these levels don't translate into actual load line slopes. So we'll just try higher switching frequency and to see if it's like something to do with that. All right, did I switch us back to VCC Sense? Yeah, let's go back to like the default. Oh. Nope, nope, that's still... Oh, well, this time it's lower, I guess. It still looks really bad, though. It kind of looks like the fact that these peaks get progressively taller is like... I find that somewhat suspicious. Actually, you know what? I'm not even gonna have it on single. We're just gonna let it run. Because I want to see what the highest thing the oscilloscope records is. Okay, we're still getting like 1.57. Yeah, so that's some kind of anomaly with the power delivery on this board. I don't think it's my probing technique causing that, because we don't see it all the time. Right? It only happen, but I'm still not sure why it would only happen during startup though. Like, you should be able to trigger that like manually somehow. So I guess that doesn't rule out my probing technique, but yeah, I'm not sure what's up with that. It is somewhat concerning, but I mean, well, I guess one way to prevent it would be to just make sure the CPU isn't already above 1.5 volts under any circumstances. Because if that event happens with a lower starting voltage, it's not going to end up at as high a peak voltage. Right? If you started it at 1.4, it would peak at like 1.45 or something, instead of what we're seeing here, where it's like it starts at 1.5 and somehow ends up at 1.58 ish. But yeah, I don't even know what that is. Like, I actually just have no idea. It's well, I know it's not. I know it's not a vid request, but like what it is and why. Yeah, I don't know. Because like it doesn't show up after the OS starts. But I can't think of like what would Windows be doing that would like trigger that. Does it like does the current draw like drop to like 0 or something, and does that like cause an... But that doesn't... I don't know. I actually just do not know. So unfortunately this video doesn't this video raises more questions, though these questions I think are directly like these are for MSI, because like maybe it's my measuring technique, but maybe my board has like some kind of VRM defect that like I just didn't notice until now. As in like there's something like manufacturing defect or something. Because yeah, if that's actually real, then like that is a problem, I think. Actually, I don't know that I would say I think. Like, it should not be spiking to 1.6 volts. Like, it's not as bad as like when the CPU sends a vid request for straight 1.6 volt. Actually, it might be worse depending on what exactly is causing it. So anyway, yeah, no, like I just... Unfortunately, this video raises questions, or a question, and I don't have an answer for this one. I have no idea what that is. It most definitely shouldn't be happening. And I don't know what to do about it. Actually, maybe the load line slopes are set wrong. Yeah, but I need to do like a bunch of measurements for that, and we're not going to do that right now. So anyway, yeah, I have more stuff to test now. Yay, I guess. Anyway, so thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with the channel, I have a Patreon, which, for example, funded the purchase of this motherboard. So without the Patreon, this video literally wouldn't be happening. Actually, none of the videos would be happening without the Patreon. You probably know I don't get enough views on YouTube for YouTube to fund the production of videos. But anyway, yeah, so I do have a Patreon. There's a link to that in the description. There's also the HOC Teespring store where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. And I've also got a Bandcamp. There's a link to that down in the description below as well. And yeah, that's it for the video. And, well, I guess I have some testing to do now. So, thanks for watching, and goodbye.